So, as Al said, my name is Matt Mishak. I'm here on behalf of the Northern Ohio Unmanned Aircraft Systems Association, or we can just say NOASA. So, the mission of NOASA is basically to, as Al said, to promote the safe and non-intrusive implementation of unmanned aircraft systems in the national airspace. And we have a focus on the local and state and regional economy, and for promoting a niche specialties in that arena. And if you look there, this is actually something we're proud of. This is our the first drone technology demonstration ever at a national air show, and it just happened at the Cleveland National Air Show this past Labor Day weekend. So we're proud of the achievement and really proud of that team up there. So I thought, as I talk about, I'm going to talk about unmanned systems, but I wanted to talk about, this is the future in the local economy here in Northern Ohio. So I want to talk about sort of how I got involved in this, and it might be shed some light on where we're going and why I believe this is such a huge opportunity for us. So in 2008, I was a new dad at that time, and basically my perspective changed a little bit. I started looking around at the surrounding community. I started thinking about the future. I started looking at what was going on. And I really didn't like what I saw. You know, the jobs that were there when I was growing up, they weren't there. The factory jobs, the area. I mean, we are the, you know, I was having a conversation with one of my coworkers actually, and he had three kids, adult kids that had graduated from college, smart kids, and they were getting out of college, and they were all moving away. You know, Atlanta and Chicago and California. And I said to him, I said, well, all your kids are moving away, aren't you kind of sad about that? And he said, well, yeah, but if I want them to be successful, and he kind of just left that hanging out there, and it kind of made me mad because, or at least upset, and it really, I became obsessed on that, is, you know, what am I doing here? What are the rest of us doing? We're just kind of holding down the fort? And do people just see this as there's no opportunity in this region? And I didn't like that idea. And when I started to look around at all, you know, we're the Rust Belt. We make things, and I think that when we make things, we feel good about that. And when we don't, we're kind of lost. We lose our identity. And the fact of the matter is, we're making less and less things. And that's why I have the picture of the elephant in the room there. I came to think of it as sort of the elephant in the room. What are we going to do? What are we going to be? And the more I started thinking about that, I thought that, look, we have so many resources. We don't just have resources as far as buildings and equipment. We have human capital in this region as well. And the thought came to mind that if we don't leverage that now, it may die on the vine, and we're just going to be stuck with this rut we have. So that's sort of where I started looking into this. So I started talking to people and finding out what could we do, how can we leverage this, how can we get out of our rut, basically. And I had a conversation with a guy from, a gentleman from Jumpstart. I apologize, I don't even remember who it was, but what he said to me, and one thing stuck out, that he said that technology companies are the Gazelles of the small business world. And I like this idea because I remember the dot-com era, and there's a lot of companies that sort of came out of nowhere and real successful. There's some that weren't so successful, but you know, that was the potential that was realized very quickly. And the idea of a gazelle sort of jumping out of the rut, I like that idea. So I kept thinking about this technology aspect. Then a friend of mine and I, we took a trip to China, and like I said, I became sort of obsessed with this concept of this area and making it out of the rut that I perceived us to be in. And so we're touring factories over China. We see that what's going on over there, and you know, we're learning about how the poor farming class people from the north are sort of moving down to the south and working in some factories out there. And a couple of factories we visited actually. The workers are living in sort of like what I would call like a Motel 6, and working a lot of hours and going back and forth, and you know, the conditions weren't real good over there. But on the plane ride back, I'm talking to my buddy, and we're saying, what do you think? You know, we had it on the mind the whole time. How can we sort of beat this dynamic that if company A pays their workers this reasonable wage and company B goes and seeks cheap labor from China, how do we get around that model? How do we get back to making things? And what we came up with was that we didn't think the Chinese manufacturers that we visited, we could tell they weren't very good at innovation. They weren't really good at high quality applications, and they weren't really interested in small run manufacturing. And actually, Mike, I was talking to one of your people, actually Brent Hartman, is no longer here, but he pointed out to me, he said, Matt, what did you say, rapid innovation, high quality, small production run? He said, Matt, that's aerospace. And so I was encouraged by that statement. So there's this other concept that I want to talk about. So we have what some people are calling the third industrial revolution. So essentially, at the time that I was sort of thinking about these things, I was working at the Fab Lab at the Lorraine Community College. And if you've never been to the Fab Lab over there, tremendous resource. It's actually the first Fab Lab outside of MIT, right in Lorraine County. It's a good resource. But they have manufacturing equipment over there. And the brains behind this whole effort is a guy named Neil Gershenfeld. And Neil Gershenfeld, I kind of think of the way he thinks about factories, like the computers. Computers used to take up floors of buildings, large floors of buildings, and then someone said, hey, one day you're going to have a personal computer on your desk, and we don't know what you're going to do with it, but you're going to have one. And I don't think a lot of people believed that at the time, that it was going to happen. Well, Neil Gershenfeld has the same idea about factories. He thought that we think of factories as being these big operations. Neil Gershenfeld says you're going to have a factory on your desk that's going to sit there, and he thinks of this idea sort of, if anybody's familiar with Star Trek, they have a device called the replicator. You say, hey, I want a tuna fish sandwich, it makes you a tuna fish sandwich. So essentially, we're getting there. If you look at the picture on the far right there, that is a 3D printer. So essentially, what you're seeing in the concept of bits and atoms is we saw the digital efficiency of electronics, right? Computers allowed us to do things a lot more efficiently. And now what we're seeing is that that's sort of manifesting in the physical world. And one of the ways it is with the 3D printer. And there's another slide later I'm going to talk about that shows you why unmanned systems or drones sort of is that same type of principle. And the important thing to remember about this is it's transformative. So it's going to be disruptive as far as manufacturing goes. And it's an important principle to remember as we look at the opportunity of unmanned systems in Northern Ohio. Whoop. So with considering all this, I was working actually at the Fab Lab one day, and somebody showed me this video. And there's this German guy. He's actually from Microcopter, and I had been familiar with radio-controlled devices, but this guy was doing stuff I never saw before ever. He was doing stuff like putting his remote control down when his helicopter was flying. You know, what's going on with that? He would fly it away. He would put soda bottles on it and let it fly, and it would adjust to the weight. And then he did the most amazing thing. He flew way away from himself. He put his control down. He walked away, sort of did a little dance, flicked the switch. The thing came back home and it landed. And I was hooked. I was hooked at that point. So that's why I became interested in these things. And considering everything else that was going on, I said, this is it. I think this is it. And that's why I thought so. So we talk about unmanned aerial vehicles, unmanned aircraft systems. What's the drones? What's going on with that? Well, essentially, when you talk about an unmanned aerial vehicle, you're talking about the vehicle itself, the craft. Okay, so that's just the vehicle itself. When they talk about unmanned aircraft systems, it's so much more than that. It is the aircraft. It's the systems on board. It is the ground station. It's the joystick. It is your payload, your camera, your sensors. So that's what they mean by unmanned aircraft systems. This is the term that FAA is going to use for this area. So why do we want to use unmanned aircraft systems? Well, our buddy here, Otto, is a great reason for it. Otto Lilienthal is the glider king. So he essentially had this hang glider, it's a really hang glider he built. Crowds of people would come see him demonstrate this, and one day it didn't work out too well for Otto. And those in aerospace maybe have heard this story, but Otto stalled out in the air and he fell to his demise. So one of the reasons we want to use unmanned aircraft systems is because manned flight can be dangerous. That brings me to the 3Ds. So unmanned aircraft systems are applied on a dirty, dull, and dangerous basis. So dirty might be that we have hazardous materials, we have toxic chemicals that maybe we need to check out, we need to get in that area, and it's just too dangerous for people or a manned aircraft to get in there. Dull, search and rescue missions, mapping, monitoring vegetation, these things take a lot of time. They're kind of, just dull things that need to be done. So that's a great application, and obviously dangerous applications where people are shooting at you or otherwise. So, anybody have an idea what the first unmanned aircraft system might have been? Show the slide for a second. Anybody?
Target.
B-52s.
B-52.
Yeah, 1950.
I know where you're going with that. No?
Rubber band powered models in the late 1800s.
What's it? Battery powered.
Rubber band powered models.
Oh, that's good. Like the paper airplanes, pretty much. Actually, it goes back a little bit further. You had a guess?
Kettering bug.
That is, I'm going to get to that. That really is the right answer. But what I'm talking about goes back to actually 181 AD with Zhu Geiling. This is if you think about it, this is a lantern powered by the light inside, and it actually flew. So I know I'm way off course with this, but this actually this is not a new thing. Unmanned aircraft systems are not a new thing. So then we come to our buddies, the Wright brothers, right? So for thousands of years, men have dreamed about it. 500 years ago, Da Vinci sort of reached for it, but it was these guys, two bicycle mechanics from Ohio, Dayton, Ohio, who actually did it and made their first flight on December 17, 1903. So does anybody have an idea what inventions might be necessary to sort of take the Wright brothers to getting to an unmanned aircraft system or a drone? What's required there?
Airfoils.
Airfoils, okay. Wind tunnel. Okay. Well, you're talking about the wing warping aspect. I'm really talking about, say that the Wright brothers have their plane, is flying well. How do we make it an unmanned aircraft system? How do we make it into the next level? Maybe the question's vague, but essentially it comes down to the advent of radio control and the autopilot. So it's radio control and autopilot. So. And we have a couple amazing guys that enter into this equation, and that is Nikola Tesla and Elmer Sperry. All right. So these two guys come up with the necessary ingredients to make these things fly without any people on board. And so Nikola Tesla, believe it or not, in 1898 comes to the New York Fair with the first ever demonstration of radio control, period. But he has a radio-controlled submarine with lights on it, and he can move it around. It has anti-interference programming in it, so somebody can't hack into it. And later on, it would actually submerge and go through there. So he comes out with this. Rumor is he gives it to the U.S. Army. Says, "Hey, I got this thing." And the Army said, "What are we going to do with that? We have no idea what's going on there." So 1898. Think about that. So then we have Elmer Sperry enter in the equation, and he comes up with the gyro compass, which is all based on the gyroscope, but also it basically is rigidity in space and also navigation based on the Earth's rotation, and it allows this aircraft to sort of have a reference point. Now his son sort of stands on his shoulders and comes up with the autopilot and the artificial horizon. So basically we have the gyro compass, which is a rigidity in space as a reference point for the aircraft, and his son Lawrence comes up with a mechanical linkage that allows that to link to the aircraft and basically navigate itself based on that autopilot. So those two inventions come together, and of course, let me show you a shot of that. So this is you can see that line there. That's the artificial horizon, and that's the gyro compass. So it's a pretty amazing invention, and it actually worked on gyroscopic heading indicator and attitude indicator that hydraulically operated the elevators and rudder and ailerons connected, so it allowed it to maintain stable flight. There's actually one experiment he did way back that allowed the aircraft to fly actually for 30 miles without any, 30 hours without any pilot intervention. And as all good scientists, he made good use of his invention. Lawrence Sperry actually is credited with founding the Mile High Club as well. So what do you think that somebody I think you did, you talked about the Kettering bug, carrier torpedo. So we had the first flight in 1903. When did we have the first drone flight? Do you know when it was? You talked to Kettering.
Yeah, I don't know, it's 1918.
Wow, that's right, it's 1918. And where did it happen? You know where it happened?
Right here.
Right here in Ohio, yeah. The first drone came from right here in Ohio, and it actually came, so we have the technology of Nikola Tesla, the technology of the Sperrys, and then you have Charles F. Kettering, who designed all kinds of aircraft, and then you had Henry Ford that came in and put the engines into this thing. So pretty amazing story of American innovation there. So there's all this debate about the D word, unmanned aircraft systems, and drones sort of ominous out there. Anybody have any idea where the word drone came from?
Bees.
Bees, that's right. That's the answer. So here it is. What kind of bee? This is the
Male.
It's the male bee, right? And so drone is all ominous, but this is the male bee. He doesn't even have a stinger. I think his only responsibility is to kind of hang around with the queen bee. So I mean, not so ominous. So that doesn't tell the whole story, right? We have a male bee, but why do we call unmanned systems drones? Well, it comes back to this in the 1930s, this de Havilland gypsy moth. And this de Havilland gypsy moth was used by the Royal Air Force overseas, and they, for whatever reason, they started calling it, and I don't know if anybody knows what the reason they call it, they started calling it the queen bee. That was just a nickname. Maybe because they have a queen over there, I have no idea. But when they brought it over to the States, the Yankees, they didn't like the queen idea, so they started calling it the drone. So they called it the drone, and that's where it comes from. So interestingly enough, the Q from the original queen persists till this day. You say have F for fighter, B for bomber. Q still indicates unmanned. And this is actually the Northrop Grumman Q-47B because of that reason. This is RQ-2 Pioneer. So this was a twin boom single prop flyer, and it had its use back in Desert Storm, Desert Shield. It's kind of amazing how far we've advanced, because with all the resources of the U.S. military, the capabilities we have now versus Desert Storm, Desert Shield with this technology are actually very much improved. So this is the first drone helicopter. It's drone anti-submarine helicopter, and they actually had 700 of them produced. And this was it was abandoned because helicopters had problems. They had so much vibration on them that it was trouble for the autopilot. They didn't fly very well. And fixed wings have their own problem because they take a large footprint to both launch and recover. So enter the multi-rotor, right? The multi-rotor, that's when people think of drones, that's really what we think of. And this is great. This is low vibration, highly maneuverable, easy to control by an autopilot, and then hence why you're seeing these things all over the place. They come in all kinds of configurations. If I didn't say so, because after we're more than welcome to come up here and check out some of what we have up here. But they have a plus formation, which you see right there. That's the plus formation. It's a quadcopter, but it's plus formation. Then you have the X formation, and it goes into the hexacopters as well. As you can see that on one of the axes is the front. That's the plus formation. If it's between two of them, it's the X formation. Then you have the Y6, which actually has two motors on each axis, and you just have the front and the back reverse there, orientation of the aircraft. So multi-rotors are not new either. John Bothazat had one they called the Octopus, and so guess who had the first multi-rotor? Any idea?
Ohio.
Ohio, yeah, he had the first multi-rotor too. So I want to say about this program. This is actually Octocopter. It was abandoned because of pilot workload. So the pilot couldn't keep track. I got to speed up that rotor, slow down the other rotor to maintain the flight. It was too much, so it was abandoned in the 1924 actually. It was abandoned at Wright-Patterson. They abandoned the program. So what changed? Why do we have multi-rotors now? Well, it's what probably all of you have in your pocket. It's a smartphone. So all the technology that goes into unmanned systems and the drone technology is basically in your pocket right now. The gyroscopic sensors, the GPS, all of it is right there. So it was really the advent of modern technology that caused this to happen. And then you can see, this is a typical quad rotor system, and you see everything's on there. You have motors, and you have electronic speed controls, you have the battery, and you have the main autopilot, which is a tiny computer that has gyroscopes in it. And so there's the GPS with the compass. So it's a complicated system. To explain how these fly, maybe some of you know. But essentially, what happens is the multi-rotor, it senses its position 250 times a second, and it actually corrects that many times as well. So in the simplest sense, you have a little tiny computer, a microprocessor, that has gyros on it that senses, am I tipped over this way? And you put firmware, you put computer programming in it that knows, hey, I'm too much tipped this way, I need to speed up these rotors, I need to slow down the other rotors. So it basically knows how to do that in its most basic sense. So if you go beyond that, so if you had one of them with a basic processor on it, it would know to stay level, but it would drift, it may turn, it may change altitude. So we change those sensors based on that. We add some additional things. One of the things is on here is a barometric pressure sensor, and it senses the altitude. So now, not only does the aircraft know its orientation and attitude, but it actually knows its altitude as well, so it can stay. But we still got a couple problems. We had GPS, and we had the magnetometer, which is the compass. Now you know your heading, and you know your geospatial position. You combine that all together, and you have an aircraft that knows exactly where it is in space and orientation, and it can stay right there. And usually, if properly calibrated, these aircraft have an accuracy of a 2 foot in any given direction up to 17-mile-an-hour wind, which is pretty amazing. So, but not only can they stay in one spot, they can also be guided. And I'll show you a shot of, this is an autopilot. So since the aircraft knows where it is, it knows its height, it knows its attitude, it knows its orientation, it knows its heading, you can actually program it on waypoints. This is a sample of a ground control station where you can just map it out, just like you do on your GPS in your car. The aircraft will take off by itself, it'll fly its mission, and it'll auto land. So it's pretty amazing stuff. This is all fairly affordable as well. So we got all this great technology, but what are we going to do with it that's really practical? One of the areas that's going to be huge is precision agriculture. So essentially farmers right now, they have to, if they want to sort of look at what's going on with their crops, they have to walk the land. They have to go check it out. They have to go see what's going on. It's inefficient, it's time consuming. They don't really have a global perspective of everything going on. And there's a lot of waste. So essentially for pesticides, these are being sprayed prophylactically. They don't know where they're going to get disease, so they spray it all over our food now. They can't monitor the health of their crops for, for example, if they have mold on corn and other things. So what essentially is going to happen with this industry is that it's going to make creating food much more efficient. From weed detection to plant counting to canopy cover, crop health indexes, seasonal monitoring to see the difference in the seasons of the fields, fertilizer runoff, irrigation, pest and disease control. By 2021, a $2 billion industry, and we have activity going on in this right here in Northern Ohio. This is Jeff Taylor, who's with Event 38, and that's one of his aircraft there. And he's actually working right now. He's actually I just got a press release that Event 38 is working with another company in Ohio on some mapping software, and that's happening right here. So $2 billion industry by 2021. Jeff's taking the lead on it. Aerial photography. So originally air photography was sort of downplayed as having such a big market share. According to Colin Snow of DroneAnalyst.com, aerial photography is going to also be a $2 billion business by 2021. And we have activity locally in the area as well. Is Cleveland Aerial Media. I think we have somebody from Cleveland Aerial Media. There's hey, what's up, Anthony? And Airhead Media is a local company. I don't know if we have anyone there. But Bishop Photography, I know Bruce Bishop's here, and Brent Lane Photography in the area. So all those, we have a tremendous activity going around in this genre. This is kind of amazing because I was at a fundraiser. We had some pictures of some buildings, and people came up to me and they said, "Hey, that's a beautiful building. Where is it? I'd like to go there." And I said, "Hey, that's the church down the street, or that's the building down the street." It's an interesting way to photograph things in a new perspective that has never been done before, was cost prohibitive for. So it's kind of interesting that way. Another area is search and rescue, hazardous material, disaster response. And so search and rescue is time consuming. You have individuals out, they may have to trudge through some brush or access a bank that is hard to reach. And that means people might be in danger longer. Unmanned aircraft systems are going to take all the guesswork out of that. You can put an unmanned aircraft system maybe overnight, find the person, thermal imaging. Hazardous material response is another huge area. For example, right now, if you have a fire department that goes out for a hazmat response, they may have to send in 4 guys with hazardous material suits. Maybe those hazmat suits cost $1,500 or in excess, and they have to go in there, see what's going on. They're risking their health and safety, and after they're done, those suits need to be disposed of. So that's a big expense. and actually fighting fires and actually disaster response. So right now what happens is they have a disaster response. You have guys that need to go out there, they're looking at the area, and they have to assess where are the critical areas in this disaster. They really don't have the perspective to know. It's all relative to where the person is. This technology is going to allow them to assess what the damage is, what the risk is, get to those who need attention, and at the end all be all, it's gonna save lives. And actually, my company, full disclosure, DroneWorks is actually this is our area. This is what we're looking at doing. 178 million by 2021. Law enforcement. So maybe you've heard of this, some press lately about the Medina County Sheriff's Office, that they're flying their unmanned system, first law enforcement agency in Ohio to get a certificate of authorization through the FAA right here in northern Ohio. And actually we have Vista UAS out of Seville that is supplying their unmanned systems. $80 million by 2021 to law enforcement. So another highlight, maybe you heard about the Cleveland Metro Parks recently. Cleveland Metro Parks, they have a certificate of authorization through the FAA to actually map their areas, map the mapping for the health of the area, to better understand what's going on there. And a gentleman named Steve Mathers, incidentally works for the Cleveland Metro Parks, but he is developing software, mapping software called Open Drone Map that creates these type of maps that you see there, and that's going on right here in northern Ohio. Medical package delivery is another application. This is a drone that dispenses life preservers to those that may be drowning. This is one that delivers a defibrillator on the golf course to somebody who might be having a heart attack. So we don't know what they're going to be used for. So it's a $96 billion industry. By 2021, it's over 125,000 jobs, and we can certainly use those here. So essentially, what do we do? How do we capture those jobs? And there's every reason that Ohio should take the lead and become for this. We have all the resources to do so, and this is a term that I've sort of used and thrown about there, but I really think of Ohio as a whole, the southern part, Dayton and Columbus and Cincinnati, coming together with the northern part of the state, and as a whole, we have good marketing tools. We're the birthplace of aviation. We invented the first drone, the first unmanned system. We invented the multi-rotor, and we have tons of aerospace resources here right now. If you look, this is just something that I threw together, but NASA here, Crane, in addition to the other ones I've mentioned, Ohio Aerospace Institute, Parker Aerospace, Berkeley Lakefront Airport, the Dessus Smart Center. These things are full of sensors. So Dessus Smart Center, right in Lorain County. Discover Aviation, Lorain County Regional Airport, Cleveland Hopkins Airport. And that map over there represents the radio control clubs that are in the state of Ohio. We have a huge radio control group. These are the two main skill sets we need to succeed in this area. And I think it's very, very encouraging. So, but to be a leader in this industry, I think that we need to take on the challenges. We need to build the community. We need to solve the problems of the industry here, and that's how we revive the area, and that's how we get the jobs here, basically what it comes down to. And this is, of course, you probably heard about this. This is the drone that landed at the White House recently. Anybody hear about this, right? So it turns out it's a government employee. It didn't mean any harm. I don't know why he's flying at 3 o'clock in the morning. I guess that's still a question, but yeah. So no malice there, but it did put some red flags up there. So I think one of the things you're seeing going on here is this, that back in the day, if you wanted to learn the radio control hobby, then you would go to your local radio control club, you'd meet with somebody who knew how to do it, and they would show you how to fly your airplane, because if you didn't, you would crash, and then your hobby would be over. So, but while you were learning to fly the aircraft, you'd also learn the rules of the road, the respect, the to look out for other people and know about restricted airspace and all of this. But now that there's drone technology, people that want to enter into the radio control hobby from this avenue basically don't need anybody to show them how to fly it, because these things fly themselves. Well, I should qualify that. These things basically do fly themselves, but you probably heard of some incidents of some drone flyaways. Anybody hear about that? Interesting thing about that. So what these guys are doing, saying, well, it's just that simple, right? They started off, they wouldn't wait for their drone to calibrate its home location. These things actually calibrate their GPS position where they take off from. Well, a lot of these drones are made in Hong Kong. So they have a panic button on them, so when you're flying away and you say, oh, I don't know what I'm doing, I want to bring it back home, well, you flick the switch and it comes back home. Well, because these guys were waiting for it to calibrate, their drone was going back home to Hong Kong and taking off. So we definitely need to get with the guys that know, what's going on here, and the gals that know that the radio control clubs. So here's another. This is another sort of, good guys, but he's ended up being a sort of problem child for what's going on right now. So this is Rafael Turner. Rafael Turner was flying at the university. Anybody heard of Rafael Turner? Anybody? Look, a couple people did. Okay, so Rafael Turner, his thing is first-person view flying. So he's flying at the University of Virginia. They're paying him some money to do a campus video. And essentially what happens is he's doing kind of some reckless maneuvers, and the FAA gets involved. Well, he has a court case, and there's this sort of strange National Transportation Safety Board meeting that says, hey, a model aircraft's not an aircraft, and the FAA has no jurisdiction over it. So that idea sort of promulgates through the drone community, and people say, hey, it's the Wild West. We can do anything we want with these things. And that's a dangerous thing going on here. So that's a sentiment that's still prevalent out there, although this court case has been reversed, and the NTSB has ruled the FAA does have authority over drones and model aircraft. So this is the type of thing you're getting. So this is like 2,200 feet, ground speed. So these little tiny helicopters flying above the crowds, nobody knows any better because they're not being brought up in any type of radio control community. They don't have the benefit of knowing a pilot. They don't know about restricted airspace, and they're creating a danger because of that. We need to be a community that is knowledgeable about this to build the industry and know what the rules are. That is a key point. And this is why. It's because there's people up there. Anybody a pilot here? Wow, a lot of pilots. So any thoughts about, you guys concerned about the drones? You think it's a real possibility? Well, this is a bird that hit this windshield right here. And birds they have like hollow bones and whatever. I mean, look at this, a lot of damage. I mean, we don't want to find out what happens when a lithium-ion battery goes through a windshield. Nobody wants to find that out. So I think it's important for us to be active in the community and talk about how, what the dangers are and get that out there. And there's this rub because of that between the manned pilots, and a lot of pilots are also into radio control. Any pilots also into radio control? Wow, that's okay. See, there you go. So I think people understand, but you're still concerned about what the risk is, right? And you're still concerned about it. So I would encourage that our communities, our radio control communities, and our aviation communities sort of come together on this issue. Don't draw the line in the sand, because what I'm concerned about is that it'll continue to be the Wild West. So another thing that, so essentially when you used to be in a radio control hobby, aero modeler, you go to the RC field, you'd be flying out there. But now people want to get pictures of things, they want to be around people, they're taking pictures. And this is causing a problem actually. I want to get this young lady's name here. Okay, this is Rhea Ogden, and she was completing the running leg of the Endure Batavia Triathlon in Geraldton, Western Australia, when she was struck by this falling object. So it crashed into a building and comes tumbling down. These are the type of problems that don't give the industry very good press when this is going on. So flying around people, heavily populated areas, and these things need to be respected. That is, a lot of these things have carbon fiber blades. They're they're Ginsu knives. These are flying lawnmowers that will hurt you, and that needs to be respected. So a lot of people that just kind of go out there flying them, they're getting hurt. They turn it on in their living room, and something like this happens. Another challenge for the industry is that there are avenues available to get insurance on your aircraft, but getting liability insurance on your aircraft is something that's developing. It's not really so available. Isn't that right, Anthony? You have trouble finding liability insurance out there, and that'll be something that will develop as far as assessing the risk. And I think having a good, safe community with good standards is going to help out with that. So also privacy concerns. I don't know, did anybody see the video of the young lady? She's out on the beach, and there's a young guy, he's flying on the beach, probably perfectly within his legal rights to do so, and she comes up and punches him. Did you see that? Yeah. Well, this idea is out there. People don't like the idea of like flying cameras by them. They just don't like it. And there has to be a certain level of respect. I mean, I don't think you can go and like, your next door neighbor and put like your GoPro on a stick and tip it over the fence, right? You can tell they wouldn't like that, right? So this is an issue that needs to be addressed. And let's talk about the general misconception. So I live in Elyria, and right by my house there had been a gas leak, and I don't know if it was a scrap theft or it was a gas leak. So essentially it had been warmer, and apparently the gas was leaking when it was warmer. And then at night, about 10 o'clock, it got colder, and I know because I thought there was a bomb going off on my porch. Well, this house exploded, and it was 4 blocks from me. And I went there, and I couldn't believe the devastation. So I put up the can. Long story short, I put up my little drone. There's no people involved. It was a safe flight. I took the picture, and then there's actually one of the guys from the news crew. Actually, Bruce was there, and he said he can have that for the paper. They put it in the paper, and on the blog spot, there was people talking on there saying, "I can't believe they dispatched a Predator drone to Elyria, Ohio to take a picture of this house explosion. Imagine what our government's doing to us." So, and it wasn't just one comment. There's a lot of comments. So it was actually this little Iris helicopter, quadcopter, really very, very, very small. But just to give you an idea of the misconception out there. So in 1981, the FAA released this advisory circular. And essentially, advisory circular is not law, but it is a statement by the FAA that this is our policy, this is how we're going to go about things. And essentially, they released this, and it gives some guidance to aero modelers for their safety record, which really starts back to the 1930s with aero modeling, with Reginald Denny. And essentially, they say follow these rules: stay under 400 feet, stay within line of sight, don't fly within 3 miles of a controlled airport unless you notify that airport. Don't fly around heavily populated areas, and essentially just have normal respect for what's going on there. This is the current law, if you will, as spoken for the FAA through the history. But now we come out with the FAA Modernization and Reformation Act in 2012. And essentially what this is a congressional delegation of legislative authority to the FAA. And if you're not familiar with that, what that looks like is the Congress says to the agency, hey, we want you to enact some rules, but we're not going to enact them all for you because we don't know all the little things that your agency does. So stay within these parameters and you figure out the nuts and bolts. And that's what this is. So based on that, we have a good indication of what is prospectively what's going on. And the FAA may say that this is the current rule, forthcoming rule. That's a legal debate that's going on. But essentially I want to talk about just the difference of this. So they say don't fly near. The other rule said don't, allow the right of way to a manned aircraft. This says don't even fly near a manned aircraft. This adds the requirement can't be over 55 pounds unless certified by a community-based safety organization. This is kind of an interesting aspect because the FAA hasn't really told us what a community-based safety organization is. So it's probably the AMA, Academy of Model Aeronautics, but they haven't said that. So it's not a good way to implement it. Don't fly for a payment. So they've added this legal debate going on about that, but the original circular didn't talk about commercial activity, and in 2007 they said don't do commercial activity, and there's a debate about whether you can do commercial activity. It's a mess. I'd be happy to talk to anybody about the ins and outs of that, but contact the airport if you're within 5 miles of any airport now. So that changes. That's a big difference. Take flying lessons, fly at RC field. So what about from a commercial standpoint? Well, from a commercial standpoint, it's a whole different game. So if you're flying for recreational purposes, you can get your drone, you can follow the rules, and actually the rules of the Academy of Model Aeronautics, there's some handouts out there. If you haven't got them, get one of those. Those are the rules you want to fly by. Plus, if you join the Academy of Model Aeronautics, they'll give you $2.5 million in liability insurance, which is good. But for the commercial guys, it's kind of cold weather out there because essentially there's 2 categories. You have the commercial and you have the public operations. So for public operations like a fire department or a police department or other entities such as the Cleveland Metro Parks, they apply for a certificate of authorization through the FAA. They need to talk about their aircraft, they need to talk about where they're flying, these will fly. So that's an onerous burden for commercial UAS operators, and that's sticking on because I think the FAA is concerned. This is a new technology. They don't know where it's going. Now, they have added to that 333 exemptions, which is basically, hey, this is the rule, but if you can demonstrate that you have another process to get us where we want to go, basically fly safely and do the same thing the rules intended to do, we'll give you an exemption. And they've granted various exemptions for that. But one exemption they haven't granted is for the private pilot's license. And essentially, some would say that it's a little bit arbitrary because the private pilot's license, there's really not necessarily a skill set transference from being able to fly a Cessna to being able to fly a radio control aircraft. So that's one objection to it. Plus there's other types of categories. You have sport pilot, you have ultralights. So people are trying to wrap their head around it. And a lot of unmanned aircraft systems pilots, they don't want to be pilots, you know, maybe they don't want to fly. Maybe they're scared of the danger, so they don't want to go through the process. So there's a lot of objections to that. So I think that one of the ways that we could move the industry forward is for our rich aviation community and our radio control community to sort of come together and come up with a training process that allows the FAA to feel comfortable about how it's proceeding and one that makes sense. I don't know if a private pilot's license makes sense. So there's sort of, you probably heard some, maybe you've seen, anybody see some press about unmanned pilots objecting to unmanned aircraft systems, they don't want them? There has been some press about that, but I think it's a dangerous thing because those that want to do this are either going to come up through a regulated system or they're going to sort of go outside of that. And I think it's important in Northern Ohio for those communities to come together and come up with some sensible training processes. And one of the groups that's working on that is FASTAR, and it's a guy named Drew Ferguson is actually in the back, and he's a commercial rotorcraft pilot. And he's doing some training. And actually, Drew was talking about, in the book for training on an actual helicopter, he was talking about the skill sets, what they have the helicopter do, fly in certain maneuvers. And it looked like it had a lot of transference to the unmanned aircraft systems, that you could demonstrate the same skill set while operating unmanned aircraft systems. This is a huge opportunity. If we can solve this particular problem, if we can come together and make a sensible training process, that we can have manned aircraft pilots, commercial pilots, especially the rotorcraft guys, because those guys are flying 300 feet sometimes, they're really they're the ones that are most in danger. If they can back this program and have radio control guys come in and share their wealth of knowledge, I think we can come up with a sensible training program. And what FASTAR is doing with Davis Aerospace and Maritime is very innovative, and there's nothing like it, quite like it anywhere else. You're going to see some STEM training, and you're going to be seeing some training of some of the youngest unmanned aircraft systems, pilots and maintenance and construction and programmers out there, and this is just a great program for that. So with that, that's the end of my presentation. I'll get some lights, and I will be happy to answer some questions.